Hi, everybody. So this is going to be our second lesson for the week. And then we'll check in together Friday at 9:30. So just want to give you a heads up. I'm going to post this on Thursday morning so that you can look this over and maybe get a little bit of it done and then come to the 9:30 session with some questions. So we'll start with our warm-up on assessments, adding and subtracting decimals again. So just remember to line up your decimal points. And you're on your honor not to use a calculator on those. I need you to practice adding and subtracting decimals without a calculator. And then we're going to move on to a lesson on scaled relationships within scaled copies. So a couple things to just mention. We're going to talk today about corresponding angles. And remember that word corresponding from last time means the ones that match up. So if I have, let me slide this down a little bit here. If I have these two shapes here, the corresponding sides would be the sides that match up after the scale factor has been applied. So let's say 6 and 4 would be corresponding sides. We can also talk about angles that are corresponding, like this angle and this angle would match up, so they would be considered corresponding angles. All right, we're going to get back to that example in a minute, but back up here. Just something to keep in mind. If two shapes are scale factors of each other, or scaled copies of each other, then their corresponding angles will be equal. Okay, so that's important. If you have two drawings or two figures and they are scaled copies of each other, then they will have equal corresponding angles. Okay, so again, if I look down here, these two W's are scaled copies of each other. So if I were to check this angle here, angle B, and then also angle I, they should be exactly the same measure. Okay. And then we talked about corresponding sides. Again, those would be the sides that match up after you've applied the scale factor, after you've made that figure either bigger or smaller. And then we're going to talk about another thing to check, and those would be corresponding distances. So for example, back on these two W's, if these are scaled copies of each other, then if I measure the distance from A to E, and I also measure the distance from H to L, the same scale factor should apply between those distances, even though it's not an actual side length of the drawing. Okay? So corresponding sides and corresponding distances will all use the same scale factor. And I'm going to go over one of the examples with you with this W. Okay, so in your, let's see, where am I? In your student task statements, the first document that I'm going to share with you, this is actually in the section labeled 4.2, and it's number 3. So 4.2 in that section, number 3. I'm not going to have you do everything on there because it's quite lengthy, but this is one that I want to talk about because I think it's pretty important. If we get this problem down and this makes sense to us, then we have a good understanding of scaled factors and scaled copies. All right, so on this problem, so we've got the two W's, and we know that from A to B, that side length or that line segment has a length of 6. And over here, the corresponding side, HI, has a side length of 15. So I want us to figure out what the scale factor is from the first W to the second W. So how do we go from 6 to 15? And remember from earlier in the week, we talked about how we can just use those side lengths to get our scale factor. So first of all, is the shape getting bigger or smaller? Did the W get bigger or smaller? It got bigger. So that means we need a scale factor that is more or less than 1. It's got to be more than 1 if the the figure gets bigger. So I can write either 6 over 15 or 15 over 6. So it's either 6 over 15 or 15 over 6. And I think we can all agree that the one that's bigger than 1 would be 15 over 6. Now here's where you can use a calculator. I'm all about using a calculator on something like this. To get the scale factor, we've got that fraction, that ratio. We can think of that as a division problem. Numerator divided by denominator. So if I do 15 divided by 6, I will get 2.5 or 2.5, and that is my scale factor. So the scale factor from the small w to the big W is 2.5. Now, we're going to use that information. Now that we know what the scale factor is, we can use that information to find other measurements. So in this particular problem, it's telling us from A to E is 4. So I'm going to do like a little dotted line and label that 4. And then it's going to say, how long is the corresponding distance in the second figure? Well, the corresponding distance would be the one that matches up. So it would be from H to L. And it would use the same scale factor. So I'm going to multiply 4 by the scale factor, 2.5. And again, you can use your calculator. 4 times 2.5 gives us 10 for that distance. Okay, so we use the same scale factor. The corresponding sides, corresponding distances, we'll all use that same scale factor. Next problem says if IK equals 5. So IK meaning from I to K. If that is 5, how long is the corresponding distance in the first figure? So it doesn't even tell you what that corresponding distance is. So we have to use what we know. We know that it would be from B to D for the corresponding distance. We know it gets smaller. So if it gets smaller, we're going to divide by the scale factor because we've got to make it smaller. So 5 divided by 2.5. Again, if you need a calculator, go ahead and use it. 5 divided by 2.5 equals 2. Okay, so we are using that knowledge to find some different side lengths and also some just different distances within the shape. And the last thing that I want to go over with you is in 4.3, number 5 gives you a drawing, a couple of figures that look like this. And at first glance, you might think that they are similar, that they are scaled copies of each other because the corresponding angles match up, right? 60, 60, same here. 120, 120, same here. And we know that if two shapes are scaled factors of each other, then their corresponding angles are equal. However, that doesn't guarantee that they are scaled copies. So now let's look at the corresponding sides and see if we have the same scale factor. So there are lots of different ways we can do that. If I have this side here that's 2, and that corresponds with this side here that's 1, what would we say the scale factor is? Well, if we're going from a bigger shape to a smaller shape, it has to be less than 1. So are we going to put 2 over 1 or are we going to put 1 over 2? Well, obviously, we need it to be less than 1 because the shape is getting smaller, so the scale factor is 1/2. Now let's see if that works with the other corresponding sides. If this side here is 4, what's half of 4? Not 3, right? And what about this one? If this side is 6, what's half of 6? Not 4. So these are actually not scaled copies. So that's an important thing to keep in mind, that just because the corresponding angles are equal doesn't necessarily mean they are scaled copies of each other. But if they are scaled copies of each other, then the corresponding angles will absolutely be the same. They will be equal. Okay, so I'm going to post this on Google Classroom so you can watch this video And I'm going to give you a few different examples to practice for this lesson. All right. So I will look forward to seeing you all on Friday morning at 9:30. Take care.